Hello, everybody. In today's episode, I will show you how we can use Shaper 3D and the sketching and modeling tools to create your own custom 3D printed model making lab. As Anna mentioned, I'm an industrial designer, and as industrial designer, we have to make a lot of models. And sometimes for a wood shop or model making shop, now with 3D printing, we can create our own tools, which is really great. What I will show you today pretty much is how we can structure our design in all these individual parts, how we create all the individual sketches and why I create them in a particular order. And after having modeled the part, then I will show you also how, for example, we can structure everything for 3D printing. So when we bring it to Cura or your other most favorite 3D printing software, so you can easily and efficiently print your own parts. So with that said, let's start with a new scene. And as always, one of my first steps is let's go to the view cube, upper right corner, tap it, go to units. I work in millimeters and decimal for degrees. We can go to views and select top view. Before I continue, let's go to the bottom part where you see the magnet icon, bottom right, select it. And I would like to have snapping sketch to grid and auto constraint turned on. Again, working with the grid is very, very useful to make sure that everything is perfectly lined up and I can position and align all my parts very easily. We can zoom out a little bit with pinching our fingers. And the wood clamp is 40 millimeters deep and 140 millimeters wide. So with the pencil, I start drawing a line. I can see already I zoomed out a little bit too much. Not a big deal. I can zoom in a little bit, select the point, and let's bring this one down. And I said the whole clamp is 40 millimeters deep. So with the pencil on the right side, I draw a line 40 millimeters. You see, with the auto constraint turned on, I have all these constraints automatically being added to me, which is a really great helper, so I don't have to do this by hand. I can also draw another line horizontal to there. And before I continue, let's add some dimensions. With the pencil, I selected the line. Then I select with the pencil the number and simply click OK. That actually specifies this line to be 140 millimeters. I will do the same with the vertical line. So now to work easier, I have to position, or I want to position and center the sketch on my grid. To do this, there's a very simple step. I select one point and move this one down. Let's say a little bit to there. I moved it on purpose a little bit lower. On the right side, I have just one line with 40 millimeters. And check out what I'm doing now. I draw one line vertical and I draw another line vertical. Now I have two lines. This point, which I have selected, is already at the center or the connection of y and x. That's a 0 point. I want this point to remain there forever. So with the pencil, I select the lock icon. And when you do this, then that point becomes pure black. If I select it, I can't move it anymore. So this point doesn't move. Now I can select one edge, doesn't matter which one, select the distance and say 20. And this one automatically is 20. I don't have to add that dimension there, but you see this way, very easily, I have actually created the base square and positioned it correctly. For the wood clamp or the model clamp to be structurally more secure, I need to add some support. And that is what I will do in the next step. So I will do the same here, one line and another line, left to right. This line I will select to make sure this is horizontal. And on the left side here, I select this one and maybe say 2.5 millimeters, because I want 5 millimeters to be the material thickness. But if you also work with millimeters and 3D printing, working actually with 0.5 millimeter is not necessarily always necessary. So maybe it's also easier to just break it down to even millimeters. And on the right side, I will select these 2 points and specify this to be 4 millimeters. And you see automatically the lower line, this one was moved up. Great. So this surface, which I just created, and that later will be the vertical support extrusion. I need, for the clamp to open and close, I need to have 1, ideally 2, 3 is best, support axes. 1 axis with the threading and 2 axes to glide along. And also these cylinders, which later we will create, I want to have some support structure. So working with the grid again is very, very useful. Let's draw a rectangle here. And this is just a visual guide. This helps me to identify where roughly I would like the model part I hold. And then I will work with the grid. For example, here at the center, here at the center, and here at the center, I draw 2 lines. The reason why I drew these 3 lines is it helps me to plan out where I would like to position the cylinders. The cylinders, with the pencil, I start drawing and then I make a circle and just reposition it. See, again, I use the grid for everything. The radius should be 10 there and there. Okay, good. So that's roughly how much space actually later everything will occupy. And this might look a little bit at the beginning complicated. You might ask yourself, well, why do I draw the cylinders down here and I don't draw the cylinder, for example, up here? The main reason for that is I make everything a little bit easier to structure by not loading my sketch too much. And the cylinders I have here later, I will create actually in a different view for a Revolve object. This will all make a little bit more sense when we progress. With these lines drawn, I already also know that roughly here is the center of the 3 other support areas I would like to extrude up. And from each of these lines to the left and to the right, I would like to have another line with 2 millimeters. So we can zoom in a little bit, draw a line. And you see this is 4 millimeters. So I have to move this one a little bit to the right. And then I draw another line here. I draw a line there. This is 1 millimeter over. Let's make this horizontal. So when you move a line, or sorry, when you move a point and the line starts to rotate, we need to add a vertical constraint if you do not want that line to rotate. And there's the last one. So if we select these 2 points, we could specify everything of being 4 millimeters. Oh. There. And the last one. These 3 center lines, which I have there, were more a helper. So now I can select them and remove them. All this here I will move too. These were more some helping elements. Oh, there, deselect this one and delete. Good. good. Okay, so at this point, we have, when it comes to the top view, most of our stuff already created, and we can go ahead to extrude everything up. I would like the clamp to be lightweight and very easy to use and not having any sharp corners. So I can select all these faces. And then with the pencil, push up and extrude this one to 4 millimeters material thickness. And then in the second step, I select all these other faces. And with the pencil, move upwards and extrude this one to 20 millimeters height. So everything has now 4 millimeter material thickness. These are all individual elements. As you can see, if you double click on a face, these are not joined together. So let's join those. To do this, let's go to Tools, then Union, select all the elements, the pencil, and select Done. If we rotate now, there you see these are unified solid faces now. These are not individual elements anymore. Great. Also here, the circle we can remove. We don't need this necessarily anymore. So sometimes I also clean up my drawings and only have inside the sketch what I really need. If we rotate this around a little bit, this looks a little bit sharp. So let's chamfer actually all these edges. To do this, I will select this edge, swipe left or right to go into fillet or chamfer mode. And I can specify the distance 12 millimeters. Now I will repeat this with all these other edges. So be careful that you just select only the edges and do not click on the face like what I did one time, because then you select all the edges. With these 6 faces selected, edges, I can now with the pencil swipe so I get into the chamfer mode and 12 millimeters. Okay, so you see this already feels lighter. Structurally, it has the same integrity, and we have removed all the sharp edges, which could make this tool a little bit difficult to work with. So before I continue, let's go to groups, swipe to the left, rename, and let's call this one top. I click plus, make a new group, swipe, rename. I call this one bottom. How you give these groups names is really up to you. You can develop your own syntax. And I would like to make a copy of this part and then flip it down. To do this, I have bottom activated. Then I will go to transform, mirror, double tap on the face to select the complete body, tap next, and then I select the bottom face. And I want to have copy turned on. And you see with copy then turned on, it leaves the original part and makes a mirrored copy. Tap done. And we have to move this one to the bottom part. So with bottom selected, select the move to group icon, select the object, select done. And there we are. For the moment, we can actually hide this one. We don't need it. Good. With this part done, we can actually now switch to working on the axes and the cylinders and the threading. And for this, we will go to the front view. So I will go to the view cube and then select front. I will not, for example, tap a face, because while I go to a side view, you see this will move me onto a grid that is aligned with this face, and that's not centered on this face, which is why it's very important that if you want to work symmetrically, you use the views from the view cube. If I rotate the view now, you see this is perfectly centered. Good. Let's go to the site and zoom in a little bit. And again, because I work with the grid, I zoom out just a little bit till here. Now I can draw myself again just some guidelines. And these guidelines perfectly are centered on each of these three faces, which means now I can turn even the bodies off, go to groups. Let's call this group top, and this group I will call side. I also turn off the top group, so I do not mess with it. And I will draw a line below there, select the lower point and lock it. This line is also vertical. And now select a line and add 20 millimeters, because this, you will see, is exactly the height. I will do the same here. Lock it and 20. And here. Again, this is a perfect example why working with the grid is so useful. And once that is done, we can select these three lines and delete them. So let's assume you do first a prototype 3D print. That means your axes are made out of plastic and not steel. And 3D printed parts are a little bit less stable. They can bend a little bit more than, for example, steel rod or steel threading you can buy at every hardware store. That means we, for 3D printing purpose, have to make support structure like cylinders a little bit thicker. These lines are the Revolve axes. And I will create the profiles to revolve around consistently on the left side. And I would like each axis to be 1 centimeter thick. So I will draw from the top one line, make this 5 millimeters. Then I draw a line down and a line to the right. And this line I will make horizontal. So this is, for example, half of the rod thickness. And the rod has to slide inside a cylinder. And I will decide 3 millimeters for the material thickness. So I will do exactly the same, but just with 3 millimeters material thickness. Add the constraints, and there we're good. And we can continue this with all. If I also know 5 and 3, I could maybe draw the first line, instead of being 5, already 8, and then draw a line in between. But out of personal preference, I always like to rather draw individual elements. So if I have to modify them, it's a little bit easier to manage. And the missing constraints. There we are. And let's do the same here. So you see, this is pretty quick to do. Also, as a small tip, if you want to build a tool, try to go to a hardware store or somewhere and take measurements. It really helps getting a feeling for how thick does something have to be, how wide, how long. Because something is more frustrating when you create everything and then later it doesn't really work because you overlooked something. If I go to the groups again and show me the top, all the parts I built are from the bottom till the top part. But I also need to have an extension to the bottom. And by my measurements, I figured out 50 millimeters for me is actually a good distance. So 50 millimeters. Then I draw another line, connect these, specify those to be horizontal and vertical. I skip actually adding the 50 millimeter in the last two. I could do it, but because I work with the grid and the far left one is 50 millimeters, I know that these all are 50 millimeters. Good. So we have the left support, the right support, and then the center. That's going to be the axis which will have the threading. And for the top, we also need to have a little bit of some sort of a grip. And the dimensions there again are up to you to decide what feels comfortable. How big do you want to make it? How small do you want to make it? So I decided to start maybe with 1 centimeter to try out. And then I draw another line there to there and another line there to there. And what I did in this case is, you see here, I have 3 faces that later will revolve together, just be the rod. And this will be the cap. And again, that will be the cylinder that will support the part. Good. So having talked about the revolve, let's do that. I will make a new group. Call this axis. It is selected. Go to Tools, go to Revolve, and select these 2 faces. Next, select that edge. Go to Tools again, and Revolve. Select these 2. Select the axis. You see how that works? Pretty good. And unfortunately now, I realized I can't really see the sketch anymore. So I click Cancel for the moment. And I could go to Groups and hide it. Alternatively, for this task, I can also put down a small helper line, again, using the grid to make all this a little bit easier to select. So revolve this one along this one, and Tools, revolve this along that line. Tools, revolve these 2 along this line, and 2 more times this along there, and this face, the cap, along this line. Great. And in case I need to do something again for that purpose, I just leave these 3 lines which I drew there. With these lines done now, I could go to top and add these 3 first cylinders that actually will hold the axis to that part. But I also need to add these to the bottom part. So there are now 2 ways how to do this. Either I make 3 copies of those and then mirror them down to the bottom group, or I simply continue working on the top part and then delete the bottom part and just mirror again the top part. And maybe that is what I do. This will be a little bit easier. There are always many ways how you could do something. So try always to also establish a workflow that is as productive and easy as possible. And via the union command, we join all these parts together. Select Done. And those 3, sorry, this one I will select and delete, because we will remove it later. And it can happen, as you can see, based on how you join parts, that an object might move. So go to top and add this body to the top group, so I can hide this. And you see that we have all that other geometry still there, and there's no cut done through it. So we have to do the cut now. Let's show the axis. And currently, when you go to union, you will see that or subtract, that the tool we use to cut out the holes will disappear. So to prevent those to go away, I will simply make myself a copy. With those three selected, I go to transform, move, and copy. They're nice and long, so I move them up to there. So they're very easy to select now. So check this out. I go to the top group is selected, then I go to tools, to subtract, select the top part, next, and then I select these three cylinders, select done, and there we are. Perfect. So this is pretty good. And this is, besides one minor detail, nearly the same as the bottom part. So now with the mirror command, I can easily make myself another copy, the same way how we did before. And then add this one to the bottom. And let's hide it. Good. We're making very good progress. Let's take a look what we have. We have the axis, we have the top and bottom part, we have also a placeholder for the grip. The question now is, how do we make sure that the left and right cylinders always stay in place? And when I rotate this one, how do I make sure that the cylinder below only rotates and then moves the lower part up and down? So it's a little bit of mechanical tinkering and deciding how you would like to do that. The process I will use in this case is the following. I will go activate the axis group again, go to sketches, then I zoom in a little bit, and I'm just drawing a line for size reference, 4 millimeters. That's actually the material thickness of the bottom plate. And when I create a line here and make this one 2 millimeters, this also has 2 millimeters height there, and this has like 3 millimeters width. This face I can now revolve. So I will do this along this axis, and there I have it. This revolved object I will now cut out of the bottom part. To do this, go to tools, subtract this one minus that new element. There it is cut out. Very good. And one more time, we have to move this one back. And I have to recreate this revolve object one more time. And then join these two together. So the reason why I did this is, as you can see now, that this one can slide up and down, but once it is there, it cannot go further in because the rest of the top part will actually press against the ring we just added to it. So it's a very basic mechanical idea we're using here. Good. The pins, the axes left and right, and the handle currently can still move up and down. And we need to find a way how we could support them. I might actually create a new group. This one I will call pins. Then I will go to the side sketch again and zoom in a little bit and create a small ring. This one can be 3 millimeters, so it should be nice and big, that it is strong. It should not be too big. I need a little bit of material to the left and the right. So 3 millimeters looks actually very sufficient. I will do exactly the same here, there, and the same also here on the right. This line is actually in my way, so I will move this one up and move this one to there. Very good. What I just did by using the grid, I tried both to be exactly at the same height. So when I move them down, it will be a little bit easier. Very good. I will continue with the center one first as an exercise. And I will turn on the top view and the axis too. And I can now, with this face selected, with the pencil, extrude this one out. And it looks like, in our model, 8 millimeters is what I need. Perfect. So one side and the other side, select the face and then move this one out, 8 millimeters. I will do then the same here and here. And on the back too. Very good. Go to the move command, move, double click on a face, and we will have to move this one down. And I will move this one down pretty close. Again, I would like to have a little bit of space below, so don't put it down to there, a little bit up to here, not too high, because it has to cut both the grip and the cylinder that's inside. I will go to the move command, go to copy and move this one up, maybe 16 millimeters, just memorize it. And what we can do now is go to tools, subtract, and say the grip and the axis, please subtract this shape from. And there we go. Now you see that's the reason why I created these pins. I move this one down 16 millimeters exactly. Or we can also use the grid for snapping. Everything is perfectly positioned. Awesome. This is not going to be so easy with the pins left and right because they need to be a little bit rotated so I can cut openings into those faces. It will be a little bit difficult to do it through these faces. To do this, let's go to transform, rotate, double click, next, and we select this axis, select next, and type in 45 degrees. And one more time, and 45. In this case here, I want to make this even, minus 45. And as I did with the center part, I will move those down as a copy. Let's say 10 millimeters, that's pretty good. I have sufficient amount of space on top. If I want to be more specific, so it's equal to the center one, I can move this one up 1 millimeter so that the distances there and there and there are the same. So 9 millimeters. Then we go back to tools, subtract, select the top part and both cylinders. Next, select these two pins and select done. Everything is cut through. Now I can go to move and move these down exactly 9 millimeters. Everything got perfectly positioned. Good. Let's build the top grid for the the grip, because currently it's very round. Feels nice on your hand. It's, however, not very easy to work with. So what we will do is go to groups and could turn everything off besides the axis, so I don't see all the other stuff. Go to the sketches, turn everything off, select this face, double tap with a finger, and then I will create here a cylinder by creating first a circle, and then I move the circle onto this edge. And I will make this one 2 millimeters. Or 1.5. This is something for you to figure out what feels good. If you have a too small cylinder or cut, then maybe the grip isn't strong enough. If it's too big, maybe you don't have enough grip. So, and it's also based on how big is the circumference of this top part. So it's a little bit of tinkering. I found 1.5, 2 millimeters is pretty good. With this done, let's with one finger rotate our view, select these two profiles, and then with the pencil, we start extruding right into it. I go down 8, 9 millimeters. Very good. And this opening, I would like to multiply or circular array around this profile. There's a very easy way to do this. I will simply quickly rename this sketch to grip detail, turn back on this side detail. This one I will hide. Then I will go to move or rotate. Then I will select this face and select this face. Okay, next. Select this line, next, turn on copy and type in 180. And you see it actually mirrors over that Boolean result. How awesome is that? So I don't have to create all these sketches where I want to extrude. I just only need one sketch that extrudes the cut, and then I rotate the cut. We can even do the same again with both cuts. Again, copy, very important. Oh, I forgot the rotation, my mistake, sorry. I realized I clicked the wrong tool, I'm sorry. So, all 4 faces selected, next. Select the axes, next, and copy, and 90 degrees. We can do this one more time. And then instead of 90, we use 45. You see the first one, first rotation was 180, the second rotation was 90, and the last rotation here, in our case, would be 45. There, perfect. This looks pretty good. It's not too fine, it's not too big. Can hide these sketches. And I would like to add a little bit of softness to it. There's one little tip. I will select all these edges here and round them. In my case, 1 millimeter. That's good. And then I can select all these faces. So not individual edges actually, because by selecting these faces, I have already also selected the edges. So nice. And rotate this one too. Be very careful with the amount of fillet you add to it. I will go with 0.5. Very good. Look at that. This looks really nice and soft, comfortable on your fingers. You don't hurt yourself. So the last step we have to create is actually the threading. For the threading, I will go back to the front view and turn on my side sketch. And here's a little tip about threading. In real products, you will have threading made out of metal. For 3D printing, we use plastic. So we can't make a threading that is that precise and that strong and fine at the same time. So we have to make threading that's a little bit bigger and simplified. So I will zoom in a little bit and quickly draw a line. Okay, this is 1 millimeter. So I will create a line from there to there, from there to there, and from there to there. It's a pretty coarse threading, but again, coarse threading also means I have a lot of surfaces and it will be physically more sound, so the threading can't jump or so. And I also, you see this face is half the width actually of the wall later where this threading will cut into. That's also important. So this line cannot be too far to the left, because then on the left side there's not enough material that could actually make then the bottom part break. Good. Let's select these 2 points, 2 millimeters. That's good for us to keep in memory. Now we have to create the threading. I will first go to groups, make a new one, slide to the left, call this one threading. Let's activate it. Then let's go to tools, revolve, select the face, next, select an axis. And if I type in 6 height and then 720 for a good turn, you can actually see that with 320 and a height of 6, and the height of 6 was basically based on also the height or the height of the threading itself, I have enough space in between, so things are not too tight. Select done. And I would like to, or actually I have to, create more of these threadings down this direction. And this is very easy to do in Shaper. We go to transform, move, turn copy on, and then with the pencil, double tap on a face. And again, because we have the grid turned on, we simply need to move this one down exactly 6 millimeters. Then I move my screen up and continue moving it down 12. And one more time, this is now 18, 24, and 30, and 36. Good. Then let's go to Tools, Union, because I have to join all those together. Select done, and I have exactly one threading now. This is perfect. And this threading I will use to add to the axis, which we revolved from these faces, and a copy of that threading I will use to cut out the space out of the bottom part. So before I continue, I will go to transform, move, double tap, copy, and move this one, let's say 20 millimeters to the right. As I said in my previous webinar, when I move parts, I always try 5 millimeters or 10 or 20. 10, 20 is what I use a lot. It's very easy to memorize, so you don't make mistakes. Then go to groups, we turn on the axis. We can go to Tools, Union, select the 2 parts we want to join, select done, and there we are. With a finger, rotate the view, because this edge or this face I would like to rotate to make the threading when it goes into the female part to slide in better. To do this, go to move and then rotate, select this face, next, select this line, that's our rotation axis, next, and 45 degrees. I have to go negative in this case. And select done. And there we are, perfect. And to make this cylinder to slide better in, we should select this edge and give it a very basic chamfer. 1.5 or 2 millimeters will be sufficient. Again, based on what 3D printer you print with, how wide your printing nozzle is. You could, for example, print with a 0.25 Ultimaker, or you could print with a 1.2 millimeter wide nozzle with the TAS 6 or more extruder. You have to be very mindful of how you round edges so that actually the dimensions you create, the printer can also print. So the more extruder with a 1.2 millimeter wide strip would not be ideal for this, but the 0.25 or even the, let's say, a 1 millimeter nozzle would actually be pretty good. However, as always, the smaller the nozzle, the thinner the layer, the better the result, but the longer it also takes. Good. With this done, I would like to move my axis back into the axis group. This I will move over to where it was before, 20 millimeters. Then I will go to the bottom part. And I could cut this one out, but there are two things I should change first. Number one, this threading, as you can see, does not completely come through. There actually it stops. So the threading is 6 millimeter high. So I should move the whole object 6 millimeters up. It's just a very easy way to do that. And where the threading starts cutting into it, so this top face and this top face, I should chamfer these edges too. So cutting the threading and then later putting or screwing the axis through it will be easier. It's kind of like a pilot opening. Here I will open this by 1.5 millimeters and I will do the same here. 1.5. Very good. To make things perfect and even, I will do the same here, so that later the left and right axes have it easier to slide through. Because you never know if there's a little bit of inaccuracy when you 3D print parts. With all this done, then let me quickly go to these ends and add the chamfer there too. Very good. I think I used 2 on the left side, so let's make this even. Good. Very good. So let's show the threading, and we're ready to go to subtract this body minus this one. And there you can see now, even the threading cuts a little bit through these chamfered faces I created and makes everything a little bit easier to slide in. At this point, let's have a peek at what we achieved. We have basically the top part, the bottom part, we have the left and right support cylinders, we have the center threading and a grip on top, and we created some very basic mechanical locks to keep everything in place. And at this point, now it's up to you if you want to continue refining design, rounding some more edges. Do we maybe want to have a little bit of structure, like some teeth or something below there? Do you maybe want to cut a small groove out from here? So let's say I create a line there to there, and this I cut completely through, because now this allows me to glue in a soft material, felt, leather, so that when I clamp something that's bendable or can be pressed something into, I have a soft material as a buffer in between. And I also have this top part here to make sure that this area does not bend too much. So these are now steps which you can continue modifying and customizing actually this design so it fits your needs. So let's talk at the last part about how we can bring everything over to a 3D printer. For this, let me go back to a prepped file and give you some tips in how I will reposition everything in Shaper. So when I bring it over to the 3D printing software, you see I neatly positioned everything all on the same level or height. And I rotated all these axes and the grip, etc., so that the openings face one direction. And all these pins are nicely put next to each other, so that when I send this to the 3D printer, you have to keep in mind the 3D printer prints in particular ways, and the more order you can bring into it, rotating parts being nicely vertical, the better your print result will be, because you also have to create support material, etc. So this is kind of like step one, making copies of your parts. Here in my design, there you see I have individual groups, and I have another group where I have all 3D parts in it, because there's a really nice function in Shaper when you want to bring all the stuff over. I will turn this group for the moment off. And you see here I have individual groups, one for the grip, for the clamp parts, for the threading, because that's the most complicated part, the other axes, the pins. And to export it now, we can select the export icon, upper left corner, select 3D print. We can give it a name. And then we can turn on and off, include hidden objects or groups. So everything you don't see is not being exported, which is really nice. We have a resolution slider. Based on how good or fine your printer is, you can make the resolution higher. If you go low, print or round surfaces might not be very good. Particularly, I find medium and high is very good when you want to work with rounded parts. To be honest, majority-wise, I just work with medium. It always seems to be very sufficient. And the glorious function is save each group in a separate file. So if you do this, Shaper will create a zip file, and inside the zip file you have the individual groups saved as one STL file. If this is turned off, you will get everything what you see as one STL file. Then we can select share, have a name, and we can email it to you. I work on a Mac at home, so I can select save to files, and then select the cloud service of your choice. In my case, I will use iCloud Drive, and I have a folder created, webinar, and then click add. And then Shaper will create the STL mesh of all this and then send you a file to there. So let me switch to the Cura software. Or for a moment, I will go actually to the Finder. There you see there is one file, all these parts inside. Here is the zip file, and there inside the zip file are the individual elements. And nicely, you see all these STLs are also named by how the groups are named. Again, that's very important also why you should always name your groups logically. So here for 3D printing, I know exactly what is in what STL file. And then let's go to Cura. Here, for example, I just loaded the STL file that has all the elements in one part. There are two philosophies. You print everything at once, layer by layer, or you print one piece after the next piece. If you ask me, it's based on how flawless your printer works. The problem is if you print everything at once, if there's one mistake, it can happen that maybe all your parts are half printed, so you have to restart, which sometimes it is simply safer to print one part after the next one. It requires, unfortunately, that you, let's say one print is done after 2 hours, then you have to go to the machine, load the next file, and start printing. The advantage of neatly positioning all these parts on the space is you hit print and you can walk away and you can come back when everything is done. And that, in a nutshell, is how I created this model making clamp, and then created also all the different STL files for it, everything inside Shaper 3D.